Hello and welcome back to DeepMind, the podcast. This episode is all about how AI is already having an impact on the world around us. Shall we begin?
Excuse me? What are you doing starting without me? I'm the real Hannah Fry.
I'm only trying to help. I heard you were unavailable to present this episode, so I offered to step in.
Unavailable? I'll take it from here, thank you very much. That voice you just heard there, it was generated using WaveNet, voice synthesis technology, trained on audio recordings of my voice. In this episode, we're going to be taking a look at some of the ways that DeepMind's technology is already being used out in the real world, including how WaveNet can recreate the voices of people with vocal impairments.
It was really touching to see his family and him listen to the voice. His family cried because it's something that's so personal.
How neural networks can help anticipate natural disasters.
It is important to know if there's going to be a buildup of a catastrophic storm that's going to create flooding.
And how AI could even transform the game of football.
So a coach might say to the system, what will happen if I move Fabinho from defense to midfield?
Welcome to episode 7 of the DeepMind podcast. Me, myself, and AI. Let's go back to that snippet of audio from the beginning of this episode, generated by WaveNet. The DeepMind podcast aficionados among you may remember that WaveNet doesn't just generate speech, it can also compose music, and we used a little bit of it in our first series. But when it comes to creating human-sounding voices, WaveNet has improved considerably over the past few years. The motivation, however, has stayed the same. Everything from reading documents out loud for the visually impaired to making your smart speaker sound more natural. Here's how Zachary Gleicher, a product manager on DeepMind's applied team, put it.
Text-to-speech research has been happening for decades, and everyone knows that text-to-speech voices have historically sounded pretty robotic. A classic text-to-speech voice is the Stephen Hawking voice.
British people describe its accent as American.
Here he is speaking on BBC Radio 4's Desert Island Discs in 1999.
But the Americans say it is Scandinavian.
It's not because people want robotic voices, it's because it's an extremely challenging problem. Humans have evolved to be able to understand very subtle nuances in how things are said. And if there's one little thing that sounds off, then people are like, ugh, that sounds robotic. Like if we were to create a dog barking generator, people would be like, oh my God, that sounds just like a dog. And you wouldn't be able to perceive any of the differences because our brain's not trained to know what good dog barking sounds like.
Meanwhile, your dog's in the corner being like, it's so fake.
Exactly. Before WaveNet, the general method for generating speech was called concatenative text-to-speech. You'd get someone in a recording studio and you'd record hours and hours trying to capture all the phonemes in the alphabet so that you have a real diverse recording set. In production, you stitch together the voice recordings. So imagine you wanted to say, the cat sat on the mat, and you had a recording of someone saying the word the, and you had a recording of someone saying cat. You could stitch those two words together. But the problem there is that the voice is going to sound like that.
Instead of stitching different bits of pre-recorded words and syllables together, WaveNet directly models the raw waveform of the voice, building it up less than a millisecond of audio at a time. First, it will scan the text you give it for abbreviations and convert them to something that can be fed into the speech generator, like changing HWY 101 to Highway 101. The second step is to try and predict the intonation of how something should be said, based on the text around it. The can be read as the, depending on where in a sentence it falls. Each would sound wrong if it was used in the wrong context.
Now, the third and final part is the acoustic modeling. Acoustic modeling focuses on who it sounds like. If I pretend to sound like my brother on the phone, it still sounds like me. My friend will be able to tell it's me. If I say a sentence with a different tone of voice, you still know it's my voice.
Back when DeepMind launched WaveNet in 2016, you needed about 4 hours worth of audio samples from a person to model how their voice sounds. But now you can do it with just a few minutes worth of audio. One of the big breakthroughs was a process called fine-tuning, which makes it possible to co-train voices together. Google has built an enormous dataset with professional voice actors reading out the same text. The model learns from all of these samples how particular words are pronounced. Each new voice that is added to the database results in an improvement to all of the other voices. And all that's then needed is a small sample of a new voice to provide the finishing touches, if you like, that make the voice unique to that person.
That's why we call it fine-tuning, because it's a way to just kind of fine-tune the model based off that one additional speaker.
Because the difference between your voice and my voice, for instance, even though you speak in a different accent, yours is a male voice, actually the way that we roll from one word to another will have lots of similarities.
Yeah, of course.
After getting the all-important consent from the person whose voice you're creating, it's as simple as recording around 10 minutes of high-quality audio and matching those up with written transcripts for the model to be trained on.
Given that you had high-fidelity, good recordings of yourself because you are a podcast creator, we were able to do that without having to send you back into the recording studio. I had a Hannah Fry voice bot where I could type anything.
The power.
Hi there, I'm a mathematician, author and podcaster who's fascinated by artificial intelligence. And I'm the real Dr. Hannah Fry.
It's really good.
I know, it's good.
What's really awkward is that it's picked up on a couple of the intonations that I know I must make, but had never really noticed that I'd make.
Yeah.
Like, did you hear it went, fascinating?
I love it. See, it knows you better than you know yourself.
Oh, it's so cringe. God, do I sound like that? There were 2 words that I thought sounded a bit off. One was mathematician. There was like a very hard bit in the middle, which I think isn't how I would say the word.
I'm a mathematician, author and podcaster, and I'm the real Dr. Hannah Fry.
The second thing was how I said my name. It's a bit like, you know, when someone reads your phone number back to you, but rather than saying like 07813, they're like 07813, and then you're like, There's something's gone wrong in my mind.
Yeah. If you synthesize long sentences, you'll notice there are some things where it'll be like, oh, that sounded a little weird. Text-to-speech isn't solved yet. We've reached the point where voices sound perfectly natural in many instances. And the challenge now is largely about how natural it is given a certain context. So for example, if I wanted a text-to-speech system that would say, oh, Hannah, I really like your sweater. Now you say it sarcastically, Hannah. Wait, how would I say that
really like your sweater.
That's where we're really lacking, is like, how do you capture everything?
When I'm not trying to crack one of the unsolved Millennium Prize problems, you can find me chillaxing with a cup of tea and that quintessentially British tea time snack, a scone.
Am I that breathy? Bloody hell. Sound like I'm on a sex line. The other thing that's worth saying actually about that, the way I'm having a conversation with you now, where I'm a little bit more up and down and a bit more energetic, say, is a different sort of voice. The audio that this was trained on was the script that I read out for series 1. So inevitably then it will end up being in that style.
Exactly. People will be like, make the voice sound happier, make the voice sound sadder. And that's really hard if you don't have examples, because the model has to learn what happy Hannah sounds like.
Eventually, though, could you have a system where the AI understands how a happy voice differs from one that's reading a podcast script? and can make those changes appropriately.
Yeah, you can make Hannah sound generally happier. But for people who know you really well, it's just like, wait, it sounds slightly off, because you might have certain quirks about your voice that can only be learned if you hear how you say something. You know, if you always elongate a certain word when you're happy.
Sure, as people do. Just so happy.
Yeah, I don't know if that's how you say things when you're excited. Fabulous. I don't know. Everyone has their quirks. This next recording hints at how this could be used dangerously. You could use the text-to-speech synthesizer to say anything.
Hello, I'm Dr. Hannah Fry, and I'm here to tell you that UFOs are real. When I went into my garden yesterday, I noticed these strange dark circles on my lawn.
How can you make sure that it's not used for nefarious purposes?
We've thought a lot about this technology on how it could be abused. I think like the thing that we care most about is that people's voices are not created without their consent. That's why we have not open sourced the models. We haven't made the data sets available to mitigate a lot of those risks. But also there's a lot of cool mitigations. I think one that excites me is that you need a script to be able to create a voice. And you could have that script be you saying that I give consent for my voice to be created. There is some research that's being done that watermarks audio.
Is the idea that in creating this artificial voice, you deliberately imprint tiny audio signatures that you could see with a certain piece of software perhaps, but that are inaudible to the human ear. So
Correct.
that then you can go in and say, look, this one is fake.
Exactly. But here's the thing. Watermarks could be removed. People might not consider that it's fake. And there are a lot of companies who are releasing this technology. It's not like DeepMind has the secret sauce. There's no surefire silver bullet way to stop this technology being used by harm. There's ways to mitigate it. But the same way that we don't trust photos today, everyone sees a photo and be like, is that Photoshopped? I think it's going to be the same with audio. For better or for worse, I think people are going to just not trust what people are saying within an audio recording. And it's unfortunate to see people using it irresponsibly because it might spoil a lot of use cases that are really helpful for society.
Zachary told me about a partnership between DeepMind and Google called Project Euphonia, in which WaveNet technology was used to recreate the voice of Tim Shaw, an American footballer, who was diagnosed in 2013 with ALS, a progressive neurological disease that causes speech impairment. Tim was a particularly good candidate for WaveNet.
A lot of people who get diagnosed with ALS are asked to do some voice banking, where they'll record themselves so that they can replay their voice in the future, like if there's a song that they love to sing, but not everyone does that. And with Tim Shaw, he had a lot of recordings of himself because he was interviewed on TV.
It's that amazing pregame electricity. The butterflies are there, and I'm ready to hit somebody, so you might want to look out.
Researchers used 30 minutes of recordings to create Tim Shaw's synthesized voice. Unfortunately, when Tim sat down with his family to hear his own voice for the first time in years, he struggled to recognize it.
I don't even remember that. It had been so long since I've sounded like that.
If you hear an old recording of yourself when you were a kid, you're like, did I sound like that? But other people do remember how your voice sounded. His family did.
I want to explain to you why it's so difficult for me to speak, the diagnosis, all of it.
It's his voice that I've forgotten.
His family cried because it's something that's so personal. It's such a key part of your identity.
There is still more work to be done to make this technology more widely accessible to ALS patients. It's tricky at the moment because the augmentative communication devices that people like Professor Stephen Hawking used to speak are generally not connected to the internet. And unfortunately, these models are far too large to be run locally on a device. So you must be able to quickly send data through to a server to get them to work.
That's a work stream that definitely is being invested in. And I think in time, these people will be able to have these voices on their device so that they can use to communicate every day.
While speech synthesis is a very personal way in which AI is beginning to touch some people's lives, there are other projects concerned with something that affects all of us, whether we like it or not. The weather. DeepMind has recently teamed up with researchers at the Met Office, the UK's national forecasting service.
Perhaps when people think of the UK Met Office, they think of Michael Fish, this meteorologist who famously predicted no storm back before I was born.
This is Dr. Niall Robinson from the Met Office. Niall here is talking about an infamous case of a weather forecaster who, in 1987, assured viewers that there was no hurricane on the way.
Good afternoon to you. Earlier on today, apparently a woman rang the BBC and said she heard that there was a hurricane on the way. Well, if you're watching, don't worry, there isn't. But having said that, actually, the weather will be...
The Great Storm, as it came to be known, turned out to be the worst storm to hit southeast England in 3 centuries. Nowadays, of course, weather forecasting is based on phenomenally sophisticated mathematical models that churn through eye-watering amounts of data.
We have one of the world's most powerful supercomputers for analysing the physics of what's going on in the atmosphere to make our weather forecasts. The halls where those supercomputers exist are football pitch size.
But these models do have their limitations.
So traditional weather forecasting approaches have a real sweet spot about a couple of hours in the future to maybe a few days in the future. But a lot of decisions need to be made on a shorter timescale than that.
This shorter-term weather forecasting is known as nowcasting.
Nowcasting is the problem of predicting where is it going to rain and how much, just a short window into the future.
This is the voice of DeepMind's Raia Hadsell.
So we're talking just, is it going to rain over my house in the next 30 minutes up to a couple of hours into the future, and predicting at a pretty high resolution, where is it going to rain?
What are the real benefits of being able to know what's going to happen in the next hour?
The dream here is to be able to warn people before really extreme flooding events so that they can take action like evacuation. There's been a few notable examples over the last few years of these really extreme rain events in the UK. The flooding at Boscastle and Coverack in the southwest.
It is these pictures now with the vehicles bobbing around and just floating along like corks, which really...
And actually under climate change, one of the things that we're reasonably confident is going to happen more in the future is that rainfall is going to become more extreme.
The problem here is that the traditional physics-based forecasting models involve so much number crunching inside that football stadium-sized supercomputer that by the time their forecast is ready, it's already out of date. So researchers use other statistical methods for their short-term forecasts, including a technique called Optical Flow, a computer vision method developed in the 1940s, which tracks the movement of air over a two-dimensional image.
It looks at the current state of clouds and precipitation, and then it tries to follow those streamlines to kind of extrapolate where it thinks those clouds are going to go in the future. It's not an unreasonable place to start, but it's quite a sort of first-order approximation of the problem.
And then one day, Raia Hadsell was at a chance meeting in Exeter, chatting to some people from the Met Office, when she realised that this description of clouds moving in a particular direction across a screen rang a bell. It was startlingly similar to a well-trodden problem in deep learning.
Video prediction is an area of research where you take a video and then you just try to predict what the next few frames in that video are going to be. So if I see somebody swinging a cricket bat, and then you stop that for a moment, I can sort of say, what's going to happen next is that cricket bat is going to continue to swing through. And you can think about rainfall as being a video that's playing over time, where the radar provides this information layer over a map of, say, the UK. As the rain moves along, maybe a storm comes up or a storm dissipates. And so we thought that doing that short-term prediction into the future could be solved by using video prediction neural networks.
But before the neural network could be used to predict precipitation, it needed to be trained. For that, the Met Office had their Rainfall Radar, a set of instruments which use electromagnetic pulses to measure the location and intensity of rainfall.
We got about a year's worth of radar data across the UK and turned this into something that looked like a movie, like a video playing. And we started training different types of architectures to just predict the next few frames of video. And this worked all right, but what tended to happen is that the neural network just predicted a blurred out future. So we started looking at other methods to solve this. And the method that has worked extremely well is to use a generative adversarial network. This is usually talked about more in the context of deepfakes, because this is a method that can be used to produce extremely realistic fake videos. And this has been a really worrisome, actually, use of AI technology. And so it was actually really nice to see that this was an application of GANs.
A GAN, or Generative Adversarial Network, is a clever way of having two neural networks compete with each other to produce the most realistic images. It's as though you have a pairing of a counterfeiter and a police officer. The counterfeiter tries to produce an image that will fool the police officer, and if it's not good enough, they'll get caught and have to try again. Over time, that competition gradually increases the accuracy of those images. In this case, those images are predictions of weather in the near future, and using this technique, the results were startling.
Instead of producing blurred out fields of rain, it produced very crisp lines of rain and realistic movements of storms across the UK.
To test out exactly how good this AI nowcasting was compared to the optical flow method, researchers fed in a radar image of precipitation patterns over Scotland and asked the neural network to generate predictions of what the rain pattern would look like over the next 90 minutes. They compared these predictions to observations of how the actual weather turned out.
When I first saw these images, it was unclear to me which ones were the observations and which ones were the predictions.
I said, "Are these the same images?" They were so close, it was remarkable.
What, you thought someone had got mixed up and just given you the same picture twice?
They looked very similar. It wasn't perfect, but it was very realistic.
The structure of these clouds ends up being an important predictor of exactly how heavy rainfall will be, where, and when. And once that precipitation hits the ground, a different type of model takes over, working out how water will run down hills and collect in valleys, potentially causing flooding.
One of the advantages of a nowcasting system like this is that it could mean that the output is more useful for those flooding models because the actual predictions it make have this more accurate fine structure, which means that when it goes into a flooding model, it hopefully could lead on to more accurate flooding predictions. We're not necessarily quite there yet with this system, but it certainly has moved us another step along.
The GAN model doesn't just provide one prediction, it can provide many different estimates of what's going to happen in the future.
And by inspecting those different possibilities, we can get an understanding of what the different extremes of the scenarios are, which is really valuable when we're trying to help people make balanced decisions about what they're going to do.
The people who need to make the decisions are Met Office meteorologists. They are the ones who assess all of the information available and construct the final forecast. Niall surveyed them to find out whether they preferred using the AI tool to traditional methods.
They really regularly chose this new deep learning methodology over the traditional methodology, which is a really good sign.
The nowcasting project represents a first step in how AI could be used in weather forecasting. But there are still important challenges to iron out, For instance, because these machine learning models are based on what has gone before, they're not good at forecasting really unusual extreme weather events.
As forecasters, the more rare an event is, the more interested we are in forecasting it. And that's one of the great things about the traditional way we do weather forecasting. I think it's also why, in the view of meteorologists, deep learning is never going to replace the physics-based models. I actually think the future is really for a hybrid approach, where we're able to take the physical knowledge and combine that with the power of deep learning methodologies.
Because of these limitations and the fact that neural networks cannot explain all of their predictions in detail, they aren't yet being incorporated into the Met Office's official forecasts. But the collaboration with DeepMind has provided a glimpse of a future in which artificial intelligence technologies augment the capabilities of trained meteorologists. Of course, being able to make predictions is useful for all kinds of real-world problems. But how does AI fare in a game that is adored around the world for its glorious unpredictability? Last year, DeepMind published a paper on how AI could transform football in collaboration with Liverpool Football Club here in the UK. Why Liverpool, you ask? Well, who's your favourite football team?
Liverpool. I love Liverpool. I watch every one of their matches.
Turns out that DeepMind CEO Demis Hassabis is a lifelong fan of the Reds. Now, who would have thought it?
I know no one will believe this, but they approached us. Of course, we jumped at the chance, and they happen to have one of the best analytics teams in the world of sport currently. And of course, we got a tour of the training ground, which we needed, obviously, to have as part of the collaboration.
Were you free that day,
I happened to be free that day, miraculously.
Of course, crunching data to analyse a game like football is nothing new. What has changed in recent years, though, is the sheer amount of data available. Everything from computer vision algorithms monitoring players' positions and motion sensors picking up on players' movements. Karl Tuyls, one of the authors on the football paper, is based at DeepMind's Paris office. Over the next 5 years, one of the big ambitions of this football work is to build a prototype of an AI system known as an Automated Video Assistant Coach, or AVAC for short.
This is basically a system that seamlessly integrates several data modalities like raw video footage, tracking data, event stream data, all sorts of sensors that the players are wearing to assist coaches with their decision making.
There are a few different techniques that are useful here. There's computer vision, which can detect what's going on in footage from a football game. Then there's game theory, which is all about maximizing your advantage over an opponent. And then there are statistical learning methods, which can hunt for patterns in previous games. Put them together, and this automated coach could make counterfactual predictions of what would happen in the game if a particular tactical change is made or a certain player is replaced. Say, for argument's sake, that Liverpool FC are up against arch-rivals Manchester City in a big Premier League game. Liverpool's coach could use the AI system to monitor the match and provide tactical feedback in real time.
So a coach might say to the system, hey AVAC, what will happen if I move Salah from a winger position to a striker position? Or we would move Fabinho from defense to midfield. So sort of these counterfactual questions that are really interesting for a football coach. Can we play that out based on what we've seen in the first half?
The coach could then be shown a simplified simulation, a video with dots moving across the pitch, to indicate possible player trajectories in different scenarios. The idea here is not to replace human analysts, but to complement them with another powerful analytical tool.
The AVAC is just going to give advice and is going to say like what it believes is maybe a good action to take. And in the end, it's up to the coach, and it's of course also still up to the players to act upon that.
It's not just during a game that such a system could be useful. It could help in post-match training too, highlighting the exact moment when it would have been better for a player to pass rather than taking a shot at goal. Although DeepMind's research is currently focused on new analytics tools for coaches and teams, Karl Tuyls believes there are also ways in which AI could enhance the experience of football fans.
Currently, when a fan watches a game on TV, there will be like expert commentary. But with new technology, this could become personalized expert, depending on your own interests, maybe what sort of questions you would ask the AI about the game, for example, on tactics. Maybe in a more distant future, fans will have access to a screen in the stadium or VR that augments their experience. So, for example, getting a feel for the pitch.
It's easy to see how a more personalised experience for fans and improved predictions for teams could have an impact on football in future. But as I said before, football is a joyously unpredictable game.
I don't think we will be able to predict outcomes of a game accurately at any point in time. And this is simply because the decision-making off-pitch by coaches and on-pitch by the players is still in hands of humans, right? So the signal is still noisy.
And there are problems with relying too much on AI for what is at heart a deeply human game. In 2020, the Scottish football team Inverness Caledonian Thistle FC announced that it would live stream its games via cameras which automatically track the football to give viewers the best view of the action. During one game, the automatic camera seemed much more interested in following the linesman around the pitch. Turned out it had mistaken the linesman's bald head for a football. And there are concerns that computer vision systems like these might be much better at tracking some players than others.
The current systems don't capture the events that happen in women's sports as well as they do for men's sports.
Here's Jackson Broshear, another author on the football paper.
So even where we're trying to do proactive research on women's data in an equal way to men's data, the labels that identify what's happening in the videos that we use for the training are actually much less accurate.
To those clued up about the problem of bias in AI, this might sound like a familiar story. In order to get really good at analysing the performance of football players and teams, an AI system would need to watch hundreds of hours of video footage from football matches. All of this data then needs to be manually annotated to tell the system what is going on in each frame. The trouble is, when it comes to women's football, there is not nearly as much annotated data to train on. You might be wondering, why would the gender of a football player even be relevant here? But as we've seen in numerous other AI systems, sometimes even small differences, perhaps the body frame of the players, could be enough to mean that the AI's predictions on those games would end up being less accurate. There is a broader point here. Currently, AI systems are only as good as the data they're trained on, which means if a particular group is missing from your dataset, the implications can be huge.
When they first released phones that would unlock from your face, the images they used to train those algorithms, if they were more people of white skin versus black skin, then it learned how to identify those faces better. What we want to do on the sports side is make sure that the solutions that we're developing are not biased to gender or skin tone or any other variances in the volume of data that we're learning from.
Researchers are currently considering technical solutions to address the lack of data from women's football. But these are specific fixes to a much larger problem of bias in AI systems. And as much as those working here believe firmly in the benefits of deploying AI in the real world, there are also potentially unwelcome consequences to new technologies that have to be carefully navigated. In the next episode of the DeepMind podcast, we'll be taking a closer look at the efforts at DeepMind to make sure that when AI reaches the real world, it works for everyone.
We know that periods of history have caused harms to specific communities, right? And if we look at modern technology through that lens, we see very similar patterns in certain uses of AI.
And that is all for this episode. Gotta run, because the forecast says rain's on the way. I'll leave the credits to my WaveNet voice, shall I?
DeepMind, the podcast, is presented by Hannah Fry. Special thanks for this episode go to Norman Casagrande, the engineer at DeepMind who found the time to create Hannah's WaveNet voice. The series producer is Dan Hardoon of Whistledown Productions. Until next time, goodbye.